Today's lesson is basically going to talk about the three undefined terms of geometry. They're basically the shapes or the things that create shapes. So we start with those. Those are kind of like the building blocks. The first term would be point. And basically all you need to know about a point is it has no size to it and it's named with a capital letter. A point would look like a little dot with a letter next to it. Usually we capitalize the letter, and we would pronounce this point A. The next term is line, and again, there's no definite size to a line, so it could be as thick or thin or as long or as short as you want it. And lines go on forever in opposite directions. So there's an example of two different lines. Sometimes you'll see a line with two dots on it, 2 points on it. Other times you'll see a line with a little italicized letter. So those are the two ways to see it. And they're pronounced line AB and line M. The last term is plane. Again, a plane has no size. It can be as big or as small as you would like, or as long or short as you like. And it requires at least 3 points in order to exist. So basically, a plane is like a two-dimensional figure. So you need to have at least 3 points to make a plane. Most times we'll draw a plane like a rectangle or a parallelogram, and there's 3 letters on it that you could use to name the plane. So in this case, we would call the plane MRX. Some other vocab words we see is space, and space is just defined as the set of all points that exist in our imagination. A good way to think about this is to think about the stars in outer space. We know that there's a lot up there. We can't really count them. They're out there. Collinear means points that are on the same line. So here is a line, and you can see that all 3 of these points are on that line. So we call them collinear. Coplanar means points on the same plane. So if I draw a triangle, for example, is a plane because it has 3 points. So we see the letters Q, P, and S. They're all on the same picture, so they are on the same plane. And again, we'll practice with that. So if you look at the figure on the right, we have line M with the points Z, Y, and W on it. So we would say that Z, Y, and W are the collinear points because they're all on line M. If you had to pick 3 non-collinear points, as long as in your group of 3, one of them's not on the same line, you're good. So for example, Z, X, and Y. If you look at those, Z, X, and Y, those are not on the same line. In other words, you didn't just continue on the straight line, you had to bend your line. So the line connecting them is not straight. You could also go with Z, X, and W. Again, you cannot connect Z, X, and W with one line. You'd have to bend it. You could also do X, Y, W. So any of these would be fine. So we're just going to do some yes or no to see if you really understand the difference between collinear or not. So really quick, I don't usually draw dots on the line for you, so put your own dots in for these letters. All right, so if I look at R, X, and F, yes, I can connect them with a line. So the answer is yeah. M, X, and R, no, because I have to bend my line. T, P, and R, that would be a no. Again, you can't connect them with a straight line, it bends. F, P, and T, definitely not. And X, T, and M, yep, they are all on the straight line, so that's a yes. So another thing that we're going to do is name lines. If you're looking at line M, so really quick, I'm going to highlight that line. You can pick any 2 letters on this line and name it that. So we could say line, I don't know, let's pick E and C. You could also call it line FE. You can also have the letters reversed, the order doesn't matter. So we'll change gears, we'll look at line EP. And if you can't tell, point E is right here. Don't forget that that's a point. So EP would be this line right here. And you can pick any letters you want. So maybe you want to pick D and P. You could also pick E and D. Lots of ways to name lines. All right, planes get a little bit trickier. I want you to think of a plane as a surface. You can name a plane using any 3 letters. So it's always good to use 3 letters to name a surface. You can get away with using 1 letter as long as it's inside the surface and not contained on another one. For example, what I mean is you can't name, let's say you wanted to name this surface right here, this rectangle. You can't name it plane C because C is on the other rectangle as well. So if you say plane C, I don't know which one you're talking about. However, you could call it plane K because K is not on the other rectangle, so I can see which one K is on. It says name plane A in 2 other ways. So if you look, A is the blue rectangle because that's the one that contains A. You can name it ACD. You could also name it plane AZD. You cannot name it play CDZ because all of those points are also on the other rectangle. So at least one of your points has to be on just the blue rectangle. Let's try it again with plane BCD. So you could call it, you could switch the order of the letters up and name it CBD. You could also technically call it plane K because K is only contained on the orange, or yeah, I guess that's an orange rectangle. Or you could call it plane CDK. So all of those are fine. All right, in the next example, this is a trick question. You're supposed to figure out how many planes are represented below. So to get you started, planes means basically surface. So basically, like how many letters can you group together? So for example, there's the top of the box. So you could say E, H, G. Remember, you only need to use 3 points. You don't need to use all of them. So that's one plane. So what I want you to do is go down through all the sides and make a list of all the planes you get. And then unpause the video when you're done. Hopefully you were able to come up with at least 6 of them. I did use 4 letters just because the directions I noticed did say 4 letters. So I'm just going to follow the directions. I got the top, right, bottom, left, front, and back sides. I think those are the easiest ones. However, there are actually 4 more planes in this picture. You just can't see them. So if you think about planes need 3 letters, what about the diagonal plane? So you could connect A, B, G, and H as a plane. So there's another one. So that's 7. And you write A, H, G, B. You could go this way, E, F, C, D. There's another plane. You could go left and down as diagonal, E, H, B, C. Or you could go the other way, G, F, A, and D. So there's actually 10 planes hidden in that simple picture. We'll come back to this section. We're not ready for that. Last few rules for you guys. A postulate or an axiom is basically just a fact. So that's something you can't argue with. So fact number 1 is through any 2 points, there's exactly 1 line. So for example, if I have the points A and B, Line T is the only line ever that will go through both of those points. Okay, no other line will go through them. Rule number 2, if two lines crisscross or intersect, they intersect at a point. So I always put a dot where they crisscross, and where I put that dot is going to be my intersection. In this case, it's point C. Rule number 3, if two planes intersect, then they crisscross in a line. So that one will be kind of easy to mess up if you're not careful. So if you look, these two planes crisscross right here. So all of that space they both have in common. So all you really do is you just pick two letters that the planes have in common, and that's the name of the line. So S and T are the ones they have in common. So you would say that they intersect at line ST. And that's about it. The last rule is through any three non-collinear points, there is a single plane. So for example, if I draw 3 points that are not in a line, there's exactly one plane that goes through it. And I could draw it like a triangle, I could draw it like a rectangle, and so on. I could draw it like a pentagon, I could do a whole bunch of different things, but there's only one surface that goes through those points. In short, that means any 3 points can be connected to make a plane as long as they're not in a line. So what we're going to do is go back and kind of revisit this problem, since now we know that the letters that two planes have in common are where they intersect. So for example, EHG and ADH are those two sides of our box, and it says to name the intersection. So you're going to find the letters they have in common. In this case, they're E and H. So you're going to write line and then EH. Next ones we're looking at are ABE, so that's the front, and CDE, which is the diagonal going from top front to bottom back. The letters they have in common are E and F. So you're going to write line EF. Number 3 says name a plane that isn't drawn out for you. So we've already done that, but you can pick, for example, since it's up here, EF, CD. And that's fine. And then it says name plane EHFG in another way. So find that plane. Looks like they're talking about the top. You could name it with just 3 letters, like G, H, and E. All right, it's the same surface that connects all those points.